I know, yet more stuff on double-blind placebo-controlled trials. I've talked about how simple and elegant these studies are, but how easy it is for things to go astray. Today, I'll do another one. And this one looks at the outcome variables and how we prioritize them. So you do one of these studies, let's say on a new antidepressant medication, and you're comparing people getting the real medication with those who get the placebo. How do you know people are getting better? Well, usually you'll define a couple of primary outcome variables, like the amount of change on a client-completed questionnaire asking about depression symptoms. They fill in the questionnaire before they start taking the pills, and after 8 or 12 or 16 weeks, and we check to see if the scores have gone down, and we're hoping that they go down more with our real pill group than with our fake pill group. They'll probably go down with both groups for two main reasons. First, depression is episodic. It tends to go away. So some people in both groups are going to get better, and probably would even if we didn't give them anything. Our hope with treatment, whether it's medication or psychotherapy, is that they get more improvement and that they get it faster. Second, expectancy. People are swallowing a pill, so they're hoping they see an improvement. And if you look for it, you often get it. So a lot of people improve even though they're just getting the sugar pills. It looks like this accounts for about 3/4 of the effect that's seen in antidepressant drug trials. Anyway, we want to demonstrate that if they're taking the real drug, they improve more. So we compare improvement scores on our questionnaire between the drug group and the placebo group. But these studies are hugely expensive, and that's putting a lot of weight on just one questionnaire outcome. So we'll usually define a couple of main outcomes, not just one. So we might get the prescribing physician to rate how well the person seems to be doing as well. And maybe we'll do a kind of binary outcome using a structured interview. Does this person meet criteria for major depressive disorder, or do they not? So that's 3 primary outcome variables. But again, these things are expensive. And if you got these people in the study anyway, why not study the hell out of them? So let's look at their scores on an anxiety questionnaire and a suicidal thinking questionnaire and ratings from their family and whether they're back at work or not and a bunch of other measures while we're at it. And we'll define these as secondary outcome variables because they're not the main reason we're doing the study. And we'll take all of these measures before they start taking the pills and after, and we'll look at the change scores. And there's a problem. We got 100 people in this group and 100 people in this group, and let's say the drug is a complete dud, no better than placebo. What are the odds that people's scores on any of these measures, let alone all of them, are exactly the same in the two groups? 0. Just random chance is going to give you some differences. If you and your buddy both flip a coin 100 times, what are the odds that you both get exactly the same number of heads? They'll be similar, but probably not exactly the same. If people getting the placebo improve this much, and everybody getting the real drug improves this much, it's obvious there's got to be something in this drug. But what if it's only this much versus this much? At what point do we conclude that there's something real going on? So we have to use statistics. And the statistics that we use essentially ask, what are the odds of getting this amount of difference between the two groups just by random chance? So if our drug is a dud, no more effective than placebo, what are the odds we'd get those differences? We use the 5% significance level. What that means is we look to see if the odds of getting this big a difference are less than 5%, if both pills are duds. That's 1 chance in 20. So if we get better than that 5% level, it's still possible that it's just random chance. That's not very likely. There's a 1 in 20 chance that we will make a mistake and say that a drug is effective when it isn't. That's called a false positive. We said there's a difference, but it was really just chance, and our false positive rate is 5%. That's pretty good. But you can see the problem coming, can't you? All this is assuming one outcome measure. If we had just one questionnaire, the odds of getting a false positive are 5%. But if we add another questionnaire, that one also has a 5% error rate. If you're using 2 questionnaires, the odds of getting at least one false positive are higher than if you just had one measure. So what are the odds of getting at least one false positive in this study? It's tempting to say, well, it's 5%, and then 5%, so 10%. And if you got 20 measures, it's getting pretty likely that you'll get at least one false positive. You might think it'd be certain, 5%, 20 times, oh, that's 100%. But actually that's not true, because by chance you could get more than one false positive, or you could luck out and get 0. As well, these different outcome measures of the same-ish kind of thing are probably correlated with each other, and that reduces the problem a bit. But we still have the issue that the more variables we look at, the more likely it is that we get at least one false positive that makes the drug look good, even if it's a dud. That's why we separate our measures into 2 groups. Our primary measures, the ones we're really focused on, and the secondary measures, the ones we're looking at as a kind of side issue. We've only got 3 primary measures, so the error rate is less of a problem than if we consider all 12 outcome measures. So let's run the study. And what do we get? Uh-oh. Your drug and placebo groups are no different on any of your predefined primary outcomes. Their questionnaire results are about the same. Physician ratings are the same. And about the same number drop out of the diagnostic category. Your treatment is looking like a dud. You just spent millions of dollars on a nothing. And that's an important outcome, but it's not as sexy as having a something. And it doesn't help the company that just spent $100 million developing the drug. So long as we're here, though, let's take a peek at those secondary measures. Oh, and look, most of them don't show differences either, but the anxiety questionnaire squeaks through at the 5% level. No big surprise. You're using 12 measures. There's a good chance that at least one of them will show a significant difference. Even if both groups got placebos, by chance it's pretty likely that you'll get a false positive somewhere. But it's tempting, isn't it? You've got a choice. You could try going to publications saying, yeah, this drug doesn't look any good. But you ain't getting a prize for that study, and the company who funded you might not be very happy. Or you could fudge it a bit. You could say, this was never a study about depression. It was a study about anxiety. Our primary outcome variable, the one we were most interested in, was the anxiety score. And look, it's significant. Once you have the data, you can look and see what came out, and then define that as your primary outcome measure. And you can demote the ones that didn't come out to secondary variables. And now you've got a success. And you can publish your study of this new anti-anxiety treatment, and everybody's happy for about 10 years until nobody can reproduce your findings, and we realize that the treatment was never really any good for anxiety either. So we've got a really simple study design. Double-blind, placebo-controlled trial. Simple, elegant, but it depends on us following the rules of science. You define your variables in advance, and you do not change that based on what the data show. Well, okay, but that's pretty obvious, right? Surely nobody would redefine their variables after they look at the data, just so they can publish a positive result, would they? Well, yeah, some of them would, and have. The result is that what you might think of as a negative trial can turn into a positive one. This isn't the rule, but it has happened. There are documented cases of the outcome variables being switched in this way. One of the clearest examples is a study popularly known as Study 329, which you can read about just by Googling it. In fact, that study is notable in part because it combined so many elements of bad scientific practice. It probably sounds stupid. Wouldn't it be easy to control for this? You define your variables, you report this to the journal that you want to publish in, or to some sort of central trials group. Look, here are the variables we're going to use in this study starting next month, and win or lose, we're going to tell you the result. Then you go collect the data, and then you report it. It's a stupidly simple fix, but it's not typically done. Now again, don't assume from this that all pharmaceutical science is bunk. It isn't. I don't want to sow unwarranted skepticism here, and I am, believe me, no conspiracy theorist. But even with these really simple research designs, there are vulnerabilities to distortion, and this can affect clinical practice unless we root them out. There's an organization working to help the science get better called All Trials. I'll post a link to them in the comments below. And by the way, I've focused here mostly on pharmaceutical studies because they've had the most focus when it comes to these issues. But exactly the same kinds of flaws can find their way into psychotherapy outcome studies. Psychologists like me sometimes feel kind of smug when we learn about these problems occurring in the pharmacological data. But we shouldn't. We have exactly the same problems, and we need most or all of the same corrective measures. It's by doing this, by preserving the basic principles of science, that we can come up with safe, effective treatments for serious problems. People are complicated. There's a lot of noise in the data. But these kinds of errors and publication biases in favor of positive studies and profit motives driving the spin on study outcomes introduce even more noise. If we don't cut as much of that noise out as we can, we're going to be limited in our progress. And unless we're willing to adhere to the principles of science, we're not doing science. If you like some of these ideas, my book, How to Be Miserable, 40 Strategies You Already Use, is available from any bookseller, online or in person.